In this video, I'll be talking about continuous compound interest with the formula A equals P times e to the RT, where R is the rate and T is time in years. So we want to put these brackets around this just to remind ourselves that we perform the exponents first before we multiply by this initial principal. P is the initial principal. So we have our question: if an initial investment of $4,000 earns 8% compounded continuously, how much would be in the account after 2.5 years? Well, I'll just write these numbers in here. The ending amount is A. The initial investment is the $4,000, so I'll put in $4,000 for P, that's the initial principal, times E. E is just a number, 2.718, dot, 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 dot. It goes on forever, but we abbreviate, just write the letter E there, raised to the power of 0.08, because we put the rate as a decimal, times the time in years, 2.5 years. And now we operate on that. Well, we perform the exponents first, and before we can perform this exponent, we need to see what this is. What is 0.08 times 2.5? Well, that comes out to be 0.2. 0.2. So I'd raise e to the 0.2 power. So e to the 0.2 power. Now e to the 0.2 power is approximately 1.2214, and it goes on and on. But this is what we will be multiplying by 4,000. So I've just calculated this part right here. So 4,000 times all of that, then 4,000 times the 1.2214 is approximately $4,885. So let's write that down. $4,885.61. Okay, so order of operations. That's the big point here, is that order of operations is very, very important with all these problems. Perform the exponents first before the multiplication. Now, this next question looks for a different variable. You're solving for a different variable. This says, if an investment earns 6% compounded continuously, so we're going to use this formula again, how much would you need to deposit initially for the account to reach $20,000 in 10 years? So how much would you need to deposit? That is asking, what will P be? Okay, so we know what the ending amount is. That's the $20,000. So I will say $20,000 equals P times e to the 0.06 times 10, because T is 10 years. Okay, now what I'm going to do is simplify this part. So e to the 0.6 is what this is, e to the 0.6. That's 0.06 times 10 is e to the 0.6. And what do we get when we calculate that? And that is 1.822. So I'll write that down. 20,000 equals P times 1.822. And then we'll divide each side by this 1.822, so we're left with P by itself, and then in the end, P is approximately equal to $10,000, 976 rather, dollars and 23 cents, and that's what you're going to need to deposit initially under these conditions for 10 years, 6% compounded continuously. So again, order of operations is very important. I hope that helped.